Trista Wang, an educator at Jinx Middle School in Tulsa, Oklahoma. I am a Share and Grow volunteer. Today, I am honored to introduce the SECC Division A project. Before we start today, let me ask you a question. Can you think of examples of sorting, screening, or shifting objects in your daily life? It may be hard to think of one right now. Let's start with a short story. Do you want to hunt for hidden treasure? You may have learned about the California gold rush, where people will seek and mine out gold from the ground. We can also do it now. You just shovel, pan, and find the right location. But where's the gold? It's only brown dirt. The best part is gold panning, like in these two pictures. This is the process of separating gold from other materials by using water. By washing the dirt away, you can see bits of gold beginning to appear in your pan. This is a really special experience, but it can be very tiring to do it all by hand. Today, we would use machines to help us complete all these tasks. Your mission today is to build a gravity-powered machine to sort out your gold, or maybe marbles instead. Okay, let me give you the introduction and rules to the SECC Division A project, which is the marble machine. Here is the overview of the Division A competition. Your project is the marble machine. The age requirement is kindergarten to 5th grade students. Students are split into two groups. Group 1 is kindergarten to 2nd grade students, and Group 2 is 3rd to 5th grade students. All contestants could register as an individual or team of maximum of 5 members. Introduction to the marble machine. Your challenge is to build a sorting machine that uses gravity to separate large or small plastic spheres, which are your marbles. Let's watch a demo video first.
Now we are going to show the procedure for testing the machine. A judge will give you a countdown, 3, 2, 1, go. When you hear the word go, that is when the judge is starting the stopwatch so you can start pouring the plastic marbles into the machine. Remember to not touch the machine during the test run. The judge should stop the stopwatch as soon as the last marble either falls into a cup or falls out of the machine.
3, 2, 1, go.
What do you guys think? But first, let's go over the important dates. March is the competition registration deadline. March 14th is the contestant-only question and answer session. March 16th is when all contestants must submit a poster explaining their designs and a video demonstrating their project. March 28th is the competition day and award ceremony. The competition day. Again, remember to send a 3 to 5 minute video presenting your materials, marbles, machine, and your ideas online. Also remember to send a picture or digital form of your poster explaining your project. On the competition day, you will need to present your sorting marble machine and show the judges how your machine works. Awards. First, the cost for registration is $0 for CIE or SNGA members. If you're wondering how to become a member, you can visit this website, cie-dfw.org/plan, for information on becoming a CIE member, or you could contact sharegrow.org@gmail.com for more information about becoming a SNGA member. If you aren't a member, the cost will be $10. Top 3 awards. Again, students are split into 2 groups. Group 1 is K to 2nd grade students, and Group 2 is 3rd to 5th grade students. The money awards for both groups are the same. First place is $50, second place is $30, and third place is $20. And for all grades, there will be 3 creativity awards, which are $20 each. 40% winners will receive honorable mention awards and medals, and all contestants will receive e-certificates for participation. Building materials. You would need a 16-ounce plastic or paper cups with a maximum quantity of 10, a 20 printer paper, popsicle sticks with a maximum of 50, 1 roll of Scotch tape, 1 2 feet by 2 feet cardboard, and a bottle of glue. What's your testing materials? 16-ounce plastic or paper cups, you would need 3 of these for testing. 25 6mm plastic spheres and 25 10mm plastic spheres. You will also need a stopwatch to help you keep the time. Building rules. Your machine should only be built from items listed in the materials section. No other materials are allowed. Your machine must be entirely gravity powered. Your machine must fit on a 2 feet by 2 feet cardboard. The cardboard will serve as a base, so it must remain flat. Your machine must collect the plastic spheres in 2 separate and removable 16-ounce cups, meaning the cups can't be a support to your machine, so they can't be taped onto your machine. You must start the test by pouring a mixture of 6 and 10mm spheres, 25 each, from a single cup in a continuous motion, meaning that you can't pause while pouring. Testing procedures. You would label 3 16-ounce cups A, B, and C. Cup C contains the mixture of spheres. Cup A collects the 6mm spheres, and Cup B collects the 10mm spheres. While testing, have a judge prepare a stopwatch and count down 3, 2, 1, go. You can start pouring right when the judge says go. Make sure you do not touch the machine during the test run. The judge should stop the watch once the last sphere either falls into a cup or falls out of the machine. After testing, remove cup A and B to count the types of spheres that fell into the correct cup. The spheres that are stuck on the machine or fell out of the machine are counted as incorrect for your score. Now, scoring. Your score will be, this formula will judge the score of your machine. 200 times correctly sorted spheres minus incorrectly sorted spheres, minus 50 times in seconds, and plus 100 times the judge's score. The correctly sorted spheres are spheres that fell into the correct cup. So the 6mm spheres that fell into cup A and 10mm spheres that fell into cup B. Incorrectly sorted spheres are spheres that fell in the wrong cup, or they are either stuck or fell out of the machine. Let's look at an example. So in this example, there are 22 10mm marbles in cup B and 15 6mm marbles in cup A, which are correct. And then there are 4 6mm marbles in cup B, which is incorrect, and 9 marbles that fell out of the machine, also. The time was 6 seconds. And by plugging this information in this formula here, your score will be 4,500 plus 100 times the judge's score. Judging criteria. These are the things that the judge will judge you on. The first thing is the research problem, which can be a description of a problem needing to be solved. The second thing is design and methodology, which is the identification of a solution and design to solve a problem. Next is execution, which is making sure your machine demonstrates the intended designs and engineering skills. Now it's creativity. Your machine demonstrates significant creativity in one or more of the criteria above. The last thing is presentation. Make sure your poster is logical and organized, and be prepared to answer questions from judges to demonstrate your understanding of your machine. And here are some terms and concepts. The first one is gravity, a force that pulls objects towards each other. This picture here is the scientist Sir Isaac Newton sitting below an apple tree with an apple falling on him. This is how he found out about concepts of gravity. The next term is panning. Does that sound familiar? Do you remember the story at the beginning? Panning is to wash gravel and sand into a pan to separate other heavy valuable materials, so like gold from the beginning. Next one is screening, which is very similar to panning. This is separating usable and unwanted materials. Now here are two additional terms and concepts. Diameter is a straight line that runs through one side of the figure, passes through the center to the other side of the figure. So this line that passes through the circle is the diameter of the circle. Simple machines. The 6 main simple machines are levers, wedges, screws, wheel and axles, pulleys, and incline planes. Maybe you can use some of these simple machines in your project. Now here's an example. This marble machine sorts the spheres by diameter. The spheres roll down the funnel to popsicle sticks. The smaller spheres fall through the gaps to cup A, and the larger spheres will continue rolling to cup B. Now you can use some of these ideas from this marble machine, but we will also like you to come up with your own ideas and maybe think out of the box for more creative ideas. Anyways, have fun with your project. Good luck.